In this video, I will talk about the importance of GCP points in drone survey. Before that, let us see what a GCP is. GCPs are defined as the points on the surface of the Earth which helps to georeference raster data, such as the drone or aerial imagery. These are the points that usually surveyors measure and mark on the ground with the help of an instrument called the DGPS. Here we can see that there are a lot of varieties of GCP, and I personally like the GCP with numbering. Here we can see that these are the GCP points that contains the numbers. The number is given to the GCP so that there won't be any confusion regarding the GCP point at the time of processing. Now we know about what a GCP is, and now let us see how the GCP is made. GCP look like a checkboard and is given black or white color because it is easy to spot from high altitudes. The GCPs are usually marked with the help of a black spray on a white background. And while marking the GCPs, you have to keep these points in mind. The individual GCP should have a size of at least 1.5 by 1.5 meter. It also should be spread out evenly so that the raster data is georeferenced properly. GCP should also be clearly visible and unobstructed. For example, if a map has to be overlaid on this photo and if the GCPs are placed evenly, then the map would be pointed to the GCPs inside the photo. And the last point is a minimum of 3 GCP points are required. The more the number of GCPs, the more accurate the data will be. Now let us move on to the next slide. So, do you know how GCP is measured? If not, let's find out. The surveyors use the average method or with the help of the known coordinates measure the GCP points. For that, they use an surveying instrument called the DGPS. The DGPS consists of a base station and a rover. The base station is fixed, and with the help of the rover, we take the data from the points by placing it on the center of the GCP. There is also a bubble on the rover. We have to keep the bubble in the center so that the rover is straight and then take the measurement. Here we can see that in the figure, the rover is placed in the center of the GCP. And this is how the GCP is measured. Now let us move on to the next slide on why we need GCPs. There are two types of accuracy, absolute and relative. Let us check what absolute accuracy is. Absolute accuracy is derived from comparing the position of the real world point data to position of the data within a processed map. Here, let us see an example. Here I will explain to you what absolute accuracy is. Let us check this figure, and here in this figure on the top side is an image of the house nearby a road in the real world. So imagine A as a house nearby a road, and the bottom is the processed map having the same house A. And here we can see in the processed map that the house is positioned in the middle of the road. Here we can see the change in position of the house. And here the map has absolute error as the house is in the wrong place. And the second type of accuracy is the relative accuracy. And it is the degree to which a given point on a map is accurate relative to the other point within the same map. Let us understand that more with this example. Here in this figure, imagine the distance between these two roads to be 14 meter in real world. And if the distance between these two roads in the processed map here below is also the same, then there is no relative error. But here we can see that in the processed map, the distance between the road is 13 meter. So here the map has relative error. By comparing the images above and below, there is a relative error of 1 meter. And this is why we need GCP for making maps with absolute and relative accuracy. And on the next slide, here we can see how the thumb rule works to place the GCPs. And as you may know, GCPs are also known as reference points. They are also used to create a model or exact replica of the world terrain. Whether or not we need to plan GCP for a project depends on the use case. If the use case is just to take measurements, then we need not use GCP. But if the use case is related to land surveys in need of positional accuracy, then we need the GCPs. And coming back to the thumb rule of placing the GCP is that whenever there is an abrupt change in the terrain, you place the GCP, and the GCP should be placed uniformly throughout the terrain. And here we can see the image is divided into four parts of 1 square kilometer each, and for each box, four GCPs are placed uniformly. And the GCPs are also placed in a way when there is a sudden change in the terrain. Next, we move on to the GCP RMSC report. Here in this figure, we can see the GCP points. This figure is a processed orthomosaic map generated from a 50-hectare site. And here the GCPs are marked as 1, 2, 3, and 4. And the GCP points are distributed evenly. Here the project required a high degree of positional accuracy, and that's why we used the GCP points. Generally, per square kilometer or 100 hectares, 4 to 5 GCPs are more than sufficient to georeference the raster data. And here, this is the RMSC report I have generated from the photogrammetry for software. And here I have used Survey and Geo Workspace to generate the RMSC report. With the help of any photogrammetry software, we can get the detailed GCP RMSC report. Here in the report, we get the X, Y, and Z error. And here we also can see the GCP number and the labels. So now you all know what a GCP is. Now let us look at what RMSE is. RMSE, or the root mean square error, is used to measure the difference between two datasets or values. Here, the first dataset is the error value obtained from the GCP points measured from the ground, and the second dataset is the error value obtained after processing in the photogrammetry software. Next, we can look how to calculate the RMSE. This is the formula for calculating the root mean square error. And here Pi is the predicted value, Oi is the observed value, and N is the number of observation. And here the Pi minus Oi values are the X, Y, and Z error values in the GCP report. And here I have substituted the values in the formula. And now let us compare that substituted values with the values generated from the report. And here you can see here that the values are almost the same. And also we can use the Excel to find the root mean square error. I'll show that using my Excel. First you need to copy the data into the Excel sheet. Here I have my data in this file. And now we need to type this formula in an empty cell. Since here I have 4 GCP points, I am going to type the formula below the fourth GCP point. This is the formula for finding the RMSC, and here I am giving the cell address E2 to E5 so that the data from the cell E2 to E5 are automatically read here. And now we get the RMSC for the X, and similarly we can find for Y and Z. For that we just need to drag from this point to the right, and now we have got the values for Y and Z. And this is how we find the RMSE in Excel. And so now let's have a quick recap on what all we have discussed today. We started off with GCPs, its uses, and how to measure and when and where to use them. And finally, we talked about what RMSE and so how to generate the RMSE values. I hope you have understood, and thank you for watching the video.